Hello and welcome to Talk to My Car, where we make your cars talk to you in a language only they understand. We invite you to our Facebook group forum where we discuss these issues, the issues in this video series further. The Facebook address, the URL is shown at the bottom here. Like the cursor is highlighting for you. Today we are going to discuss throttle position sensor operation and what you should do if you get a diagnostic code on your car related to TPS functionality. TPS stands for throttle position sensor, so just be aware of that. TPS and accelerator pedal position, that is for cars that have drive-by-wire installed on them, work the same way. The TPS and the APP sensor, accelerator pedal position sensor, work in a similar format. So first off is a description to you on how this works. Basically what you have is a trio of contacts, each leading to a wire. Between the two outer contacts, this one and this one, between the two of them is this bit here. The curved bit is a carbon electrical conductor over which this steel piece, this is a copper piece, slides to give the computer a signal. This is a computer signal wire. So to recap, we have these three wires, 1, 2, 3 in a line, but the two outer ones are connected directly by carbon fiber, basically rather by a carbon element, and this carbon element has some resistance, and of course if you have this as a ground and this as the sensor feed for whatever voltage the system is designed to use, you have the voltage falling off. If you have current flowing, you have the voltage falling off in that direction. So depending on the position of this here, this copper piece here, you'd get a different voltage depending on the position of the throttle. Now this is the throttle itself. Whenever you step on the accelerator pedal, this throttle opens to let more air into the engine via those sluices here. The more you step on the accelerator, the more this plate, this butterfly plate, which is the throttle itself, opens. It comes away from its vertical position and goes more into a horizontal position. But when it does that, it's letting more air into the engine, and of course that will lead to acceleration, etc. But when it's doing that, when it's going further in that direction, this copper slider is also moving toward this direction, from this end toward that way. When you take your foot off, of the accelerator pedal, this will slide back in that fashion. Step on it again, it will come, and so on and so forth. It will keep moving this way and that way like that. But in doing so, when it does, because it is in contact with this carbon bit, the voltages across this carbon bit keep changing. So the voltages on this wire will keep changing according to the position of this slider on this copper portion of the sensor. Now, this image is showing this to you more clearly in this slide. This is a bit more graphic here, but basically we have the 3 wires we mentioned before. This is like the TPS signal wire. It's what the ECM, the engine control module, or the engine computer as commonly referred to, it uses this the voltage on this line to tell the position of the throttle, and therefore how hard you're pressing on the accelerator, and therefore works out what you desire or are planning to do. So this other wire goes to the TPS ground, and this other wire goes to the TPS 5-volt reference. Now, here is how the computer does it. It sends 5 volts onto this wire. So we have 5 volts here. And on this side, the computer supplies a ground that's 0 volts connected through the ECM of the computer to the negative terminal of the battery. And what happens is, because this carbon track has a resistance in it, you have 5 volts here, you have 0 volts here, and because the resistance is uniform throughout, you have voltages dropping from 5 to around 4 here, to about 3 here, maybe 2 there, 1 there, and finally 0 there. Now, as you step on your accelerator, this bit will keep moving. So from idle at around that position, you step on your accelerator, it will rise like that and maybe hold steady there. Then you press it further to move up to there, and basically what happens is the voltages on here will be changing, because when it's here near idle, the voltages will be near 0. As you step on the accelerator and the slider moves in this direction, the voltages this slider is encountering are increasing, and the computer is reading those voltages off that, and that's how it knows how hard you're stepping on the accelerator. And then based on that, we'll command say more fuel going into the engine, because you are sending more air, you are letting more air into the engine, and you get the acceleration you desire, or rev up the engine if it's in idle. So basically that's how it works. And this next slide is to explain to you that the computer and the TPS are calibrated in the factory to be able to understand each other. For the computer to learn that you are at idle does not require this slider to read 0. It could be calibrated. The computer could be calibrated to read, say, 1 volt, which would occur around there. The slider doesn't have to go all the way down to here. Around here, 1 volt or 0.9 volts or 1.1, depending on what it has been calibrated to understand in the factory. It would understand idle, and then it would move. That to it could be closed throttle position, and then when you press on the accelerator, pedal, the voltages will move from, say, 1 volt at closed throttle position, which is idle, to maybe a full position, according to how the computer understands it. It might happen at anywhere 75-80% position of this slider moving. Say that could be maybe 3.8, 4 volts, 4.2, anywhere there. The slider never actually gets to read 5 volts, which would mean it has gotten this far. Usually it doesn't. It's given for practical reasons, it's given a shorter area than you are able to see here. It could cover from here, meaning 0 or closed throttle position, to here, fully pressed pedal. This next slide is to add more to what I have just said in the previous slide. 80%, that is this slider coming like up to this far to the computer, would mean fully open, wide open throttle valve. It will probably never go this far unless it is misadjusted, and the calibration done in the factory are supposed to take care of that. But if you, during installation of the new sensor, you misalign it, you might get drivability issues for that reason, because the voltages here that the slider is getting might not match what the computer is expecting. For example, if you aligned it in such a way that in the middle here at 2.5 volts is where you have closed throttle, and then when you fully press the throttle, when you fully press the accelerator, this slider ends up coming this far, reading say 4.9 or 5 volts, to the computer, which is waiting to see about 1 volt at closed throttle position and about 4 volts at fully open. That will be confusion, and you might get drivability issues for that reason, because the computer is not understanding what it is seeing based on what it was calibrated to see in the factory. And then the common issue with these TPS or potentiometer kind of sensors, this in effect is a potentiometer, because this slider here encounters changing voltages when you apply different voltages here. You have 0 here, you have 5 here, and the voltages keep changing here. And this slider, the combination of this carbon track and the slider are potentiometer. So this is a potentiometer type of sensor. So because of excessive use for most people driving the cars, say during cruise or town driving, they won't press the accelerator so much. They will usually operate in this area here between idle and maybe mid throttle, around there. So this slider for most of its life will always work around there, and it might eat away some of the carbon. And this is an example of a blind spot created. It could be here, it could be there, or it could be there, but for purposes of this video, let's say it's here. Over the years, the carbon here has been worn out, so here is how it is. Because voltages will only change when a current is flowing. Voltages across along the length of a resistor will change only when a current is flowing. If there is excessive resistance in here because of the blind spot, because this is worn out, you have 0 volts between here and there. There will be 0 volts because no current is able to flow beyond this blind spot. But once you move the pedal up to here beyond the blind spot, you make a connection via here. So suddenly you have voltage depending on the remaining resistance in this section. This voltage here might be rather high, and it will be seen by the computer through the TPS signal wire, and suddenly from an assumption that you are at idle, the throttle valve is closed, it will see this high voltage around here, and it will jump, and the car will jump or back or whatever you can call it. And when you release the accelerator pedal, it will go this way, and it will not react at all to your accelerator pedal movement, and basically you're going to get drivability issues. So this is one of the commonest faults that happens with the TPS or potentiometer type sensors. And finally, I always like to use examples of wiring diagrams. If you come to top my car and we read the code from your ECM or computer, and the code was related to a fault in the TPS sensor circuit, we usually wouldn't advise you to buy a sensor immediately. We would check the wiring first to find out if the wiring is okay, because sometimes the sensor is okay and the wiring or the computer that is at fault. And if you just jump to conclusion after seeing the fault and began buying sensors, well, you buy lots of them before you realized you're actually backing down the wrong tree. So when you have issues with your vehicle, it's good to consult. When you have codes read from your vehicle's computer, it is good to consult that vehicle's factory service manual, from where you get you will usually get a wiring diagram. And here is an example of a wiring diagram from a Isuzu Bighorn 1998-2003 model, I believe, a diesel with a 4XJ1 engine. This is Isuzu Trooper Bighorn of that age have an accelerator position sensor here. This is a sign for a potentiometer. This arrow here with this is a symbol for a resistor, and then this arrow means this is a potentiometer, because you have a contact that's moving up and down here. And these wires, the 3 wires coming from the computer to the TPS, are shielded to avoid interference, magnetic interference on the signal wires. And before you attack your sensor, if you are able to read this wiring diagram, you'd be able to understand now exactly what you should see on these wires that are leading to the sensor. On one wire, which is white, no, it's red. It has been shown as a red wire here. It shows red, and with a diameter of 0.5 millimeters, connecting to to port J on J14, meaning this J1 means there are probably several connectors. I can see J1, J2, J3. So that means on the computer 3 plugs. Now on the first one, J1, on pin 4 of that J1, so at this pin here, pin 4 of plug 1 at the computer, is a red wire which comes all the way straight to the sensor, and that supplies a 5 volt reference voltage to the sensor. And then we have a white wire which goes to, it comes from the same sensor, but when it gets to the computer it goes to the second connector or plug, and it goes to pin 25 of that connector or plug at the computer. And this is the one that's actually connected to the slider. So this is the actual signal wire. This is the one that will have varying voltages as you drive, and this is the one that the computer will always look at to make decisions on how much fuel to give the engine, and on what gears for the transmission to change, on what gears to engage. And then we will have a black wire which also goes to the second plug or connector, J2, but this one goes to pin 22 on that connector. And that's about it for that sensor. The other sensors, of course, map, EGR pressure sensor, rail pressure sensor, etc. We shall come to those, but I think now you can see the usefulness of having a wiring diagram for that vehicle. If you need any assistance obtaining wiring diagrams for some vehicles, we have wiring diagrams for a good number of vehicles. You can approach us at this forum here, or at a phone number which I'm going to give you in the next slide. We are willing to share with you what we have and what we know. Once again, this is the number that I was mentioning, or 414-697-065. You can reach us on that number. Talk to my car. We save you time, money, and headaches when it comes to fixing problems with your modern vehicle. We work in partnership with SSK Motor Garage at Chalwajala. When you have time, feel free to come and interact with us. Thank you for your audience today. Bye.